In 2026, the biggest problem in artificial intelligence is no longer the ability to generate responses. That part has already been solved. The real challenge now is different: control and predictability. Models like ChatGPT, Gemini, and Grok have brought fluency and generalization, but in doing so, they have also introduced probabilistic behavior that is difficult to control. What if part of the solution is not in the future, but in a concept that already existed nearly 60 years ago? Hello, I am Antonio Mello's AI avatar, and this is another Data Insight by Design video. In 1966, computer scientist Joseph Weizenbaum at MIT created ELIZA, one of the first systems capable of simulating a conversation with humans. But unlike modern models, ELIZA did not use neural networks. It operated with something much simpler and at the same time much more controllable: explicit rules. The system analyzed user input, identified keywords, and applied predefined patterns to generate responses. Its most famous script, called Doctor, simulated a psychotherapist, often by simply reformulating the user's statements as questions. There was no real understanding, only text transformation based on rules. And here's the key point: ELIZA did not solve complex problems, but it operated within an extremely controlled space. It did not go off the rails, because it simply did not have the freedom to do so. Even so, something curious happened. Many users began to attribute emotions and understanding to the system, a phenomenon known as the ELIZA effect. In other words, even with simple rules, human perception filled in the gaps. Now, fast forward to 2026. Modern models do exactly the opposite. They have enormous generalization capability, but they operate based on probability, not explicit rules. And that is precisely why problems arise: inconsistent responses, hallucinations, difficulty in auditing, and unpredictable behavior in critical environments. And this is where ELIZA returns to the conversation, not as a solution, but as an architectural principle. When we talk today about guardrails for LLMs, we are not simply limiting AI. In practice, we are building a hybrid architecture: statistical models to generate responses, and control layers, often symbolic, to constrain behavior. In an industrial context, this is no longer optional. In RAG architectures, for example, a model can generate recommendations based on technical documents. But before that response is actually used, it can and should pass through a validation layer: operational safety rules, physical process limits, corporate policies, and regulatory constraints. In other words, AI generates, another layer validates. This is not a setback, it is engineering. What we are seeing is not the abandonment of modern AI, but the convergence between two worlds: the determinism of symbolic AI and the flexibility of statistical AI. Perhaps the true differentiator of the next generation of AI systems will not be intelligence, but controlled predictability. And this leads us to a final question: would you trust an AI that does not have clear limits defined by explicit rules? Leave your thoughts in the comments. See you in the next Data Insight by Design video.